Hey guys, in this session we're going to be doing the linear algebra practice task. This particular problem is called the 42-kilometer race. So what I'd like you to do is on the next slide, just pause the video, have a look at the question and see if you can do some of the problems, and then I'll go through the answers one step at a time. So this is the problem here. I'd suggest that you actually pause at this point and just read through the question. Okay, so we've got 6 bullet points here that we need to work through, and that's what I'm going to be doing in the next few slides. All right, so let's have a look at the first one. Well, the first two really, but no, we are looking at the first one. Okay, so for the first bullet point, we've been asked to write the equations for the teachers with respect to the distance traveled and time. So obviously Mr. Chandikay runs at 10 k's per hour. He decides to run the whole 42 kilometers. I'm going to use certain colors just to keep track of it. So I'll go with purple for Chandikay. So which means we can say that the distance Chandikay travels can be written as 10 times t. All right. Now in your assessment, guys, if you write y equals 10x, you're not wrong, but you need to actually define what y and x is. So for example, you need to say y is the distance, x is the time. All right, so the next one is Mrs. Albertson, and she runs at 5 k's per hour, and she has a 12-kilometer head start, which means her equation is going to look like this, where we've got 5 kilometers per hour, but because she has a 12-kilometer head start, she's going to get a plus 12 as part of her equation. And finally, we have Mrs. Sneddon. She decides to walk at 2.5 k's per hour, and she has a 20-kilometer head start. So for her, the equation would be 2.5 t plus 20. Okay, now I've actually used the color system here, guys. So for you guys, it would be good if you can actually label your equations as to who the equations, like which equation is for which person. All right, so that is basically our first part. That's first bullet point that's done. Now the second bullet point is asking you to draw a distance time graph for the teachers. In the next slide, I have a grid set up, and what I'm going to do is I'm going to show you guys how to do how to actually draw a straight line given an equation. Now the best thing to do is to actually come up with how do I put this? You know, for you guys to draw a straight line, all you need is 2 points. So if you have 2 points for each person, then you can join them up and actually create a straight line. So the one thing I'd recommend is I would actually say put t equals to 0. All right, and then after that maybe t equals to 5, I guess. Okay. And the reason I put t equals to 0 and 5 is I would like to substitute for each one of them. So for example, for Chandikay, we know that the formula is t equals to 10t, and at 0, so when t is equal to 0, we have 10 times 0, and the distance he's traveled is 0. If we look at Mrs. Albertson's, hers is 5t plus 12, which means d could be written as 5 times 0 plus 12, and d is equal to 12. Okay, and as for Miss Sneddon, we have d equals 2.5t plus 20, and then 2.5 times 0 plus 20, and you have d equals to 20. So the points that we're looking at for Mr. Chandikay is 0, 0. That's one of them. For Mrs. Albertson, it's 0, 12. And for Mrs. Sneddon, it's 0, 20. Okay, so that's the first point we discovered for each of the teachers. Now we need a second point to actually join their line up. So, and this is where I'm going to use 5t. So I write the equation again, 10t, but this time I'm going to just go 10 times 5, which means d is equal to 50. All right, and for Miss Albertson, I have 5 times 5 plus 12, and so that means the distance is equal to 37. And as for Miss Sneddon, we have 2.5 times 5 plus 20, and that equals to 32.5 kilometers. Oh, well, we don't really need to worry about the km for now. Okay, so the second point that we have is for Mr. Chandikay, it's 550. For Mrs. Albertson, it's 537. And for Mrs. Snedden, it's 532.5. Okay, so we've got these 2 points for each teacher, and that's what we're going to plot on the graph, and we're going to join them up to create the straight line equations. Okay, and I'm going to show you guys how to do this in the next slide. Okay, so now that we have these points, I go to the next slide, and I've got a distance and time graph. Now notice, guys, that this time is actually on the x-axis in this particular case, and there's a little label at the bottom right corner here, and distance is the y-axis, and there's also a label here. Okay, so first I'm going to work with Mr. Chandikay. Now he had traveled 0 kilometers after 0 hours, and after 5 hours he had traveled 50 kilometers. All right, so we're getting a straight line. That's a terrible straight line, but I would recommend you guys, when you draw your straight lines, is that you actually draw this with a ruler. All right, the other thing also is that it kind of just extends past this point. Now Mrs. Albertson was at 0:12. That was her starting point. So when at 0 hours she already had a 12 kilometer head start, so which means she's going to be there. And then at 5 hours, after 5 hours, she had completed 37 kilometers, which is here. All right, and I apologize again for my non-straight line, but it's pretty hard to do it on a tablet. And then we have Mrs. Snedden, who was at 0:20, so she had a 20 kilometer head start, and then after 5 hours she had done 32.5 kilometers, so she's going to be somewhere there. Oops, hang on, let's try that again. As I said, terrible drawing skills, but for you guys, what you should be doing is making sure you have a ruler and drawing this. But also, guys, you shouldn't really stop your equations at 5Ks. We're kind of assuming that they're going to keep on running, so we'll just kind of, just draw it like that, extend it out. Okay, just to say that it's going to keep on going. Okay, so that's your graph, and now we go to the next part of the question. Okay, so after 4 hours, in this question, after 4 hours, who is in the lead? Now the first thing is, I'm going to write down all my equations. All right, so Chandikay was that, Mrs. Albertson was 5t plus 12, and Mrs. Snedden was 2.5t plus 20. So in this case, we're trying to figure out after 4 hours who's in the lead, which means we substitute t is equal to 4. So when we do this, for Chandikay, it is 10 times 4, so you're going to get 40 kilometers. For Mrs. Albertson, we have 5 times 4 plus 12, which means she's at 32 kilometers. And as for Ms. Snedden, we have 2.5 times 4 plus 20, and we're going to get 30 kilometers. So at this point, you can see that Mr. Chandikay is in the lead, so you kind of have to write that down. Okay, and that's pretty much for this part of the question. Okay, the next part. We've been asked, at what time do the teachers reach 42 kilometers? All right, so once again, we have our equations. All right, so we write down the 3 equations for the 3 teachers. So we have got, just filling it up, the 3 teachers. So in this case, guys, we are trying to figure out at what point they actually reach 42 kilometers. So in this case, we actually put d equals to 42 kilometers. And what is t? So in the first question, we have 42 equals 10 times t. So t is equal to 42 divided by 10. So we can say t equals 4.2 hours. That's for Mr. Chandike. When we look at Mrs. Albertson, we've got 42 equals 5t plus 12, which means we have 42 minus 12 equals 5t, 30 equals 5t, and t equals 30 divided by 5, which means t is equal to 6 hours. And for Mrs. Snedden, we have 42 again equals 2.5t plus 20. Rearranging, we're going to have 42 minus 20 equals 2.5t, which means we have 22 equals 2.5t, and t equals 22 divided by 2.5, which is, we got 22 divided by 2.5. So we get 8.8 hours. All right, folks. So just remember that you need a statement. So you need a statement to say Mr. Chandike finished the took 4.2 hours, Mrs. Albertson took 6 hours, and Mrs. Snedden took 8.8 hours for them to reach 42 kilometers. Okay, next lot of questions. So with this one, you've actually, I mean, I've kind of kept it quite a big question, right? I mean, the way it works is like the three teachers, when they run past each other, there's 3 meetings that can actually happen. All right. So for example, you could have Mr. Chandike and Mr. Albertson meeting, Mr. Chandike, Mrs. Snedden meeting, and then Mrs. Snedden and Mrs. Albertson meeting. So we've got 3 situations that we can look at. So what I have is I'm going to write down the equations first. So you've got Mr. Chandike's equation there, and then you've got Mrs. Albertson's equation, and then you have Mrs. Snedden's equation. So the way to do this is to actually put the 3 of the equations together. So the first one I'm going to do is I'm going to look at CK and Albertson, AN. So to do this, I just need to put the equations equal to each other. So you've got 10t equals 5t plus 12. And then it's just a matter of rearranging. So I've got 10t minus 5t equals 12. 5t equals 12. T equals 12 divided by 5, which is, I am having a slow start to the morning, 2.4 hours. But in this question, we're only asking for times, but sometimes you could also be asking for at what distance they pass each other. So to work that out, I can just, because they meet at 2.5 hours, it doesn't matter which equation I put it in, I should get the same answer. So I'm going to use Chandike's one because it's easy. So distance is equal to 10 times 2.4, which is 24 kilometers. So we can say that Albertson, Chandike passes Albertson after 2.4 hours and a distance of 24 kilometers. Okay, so the next one we're going to have a look at is CK and SN, Ms. Snedden. All right, so we write our equations. 10t equals Snedden's equation, which happens to be 2.5t plus 20. And now rearranging it, we have 10t minus 2.5t is equal to 20. So we got 7.5t equals 20. T equals 20 divided by 7.5. And for that, we have 2.67 hours. All right, and in terms of the distance, I'm just going to use Chandike's one. So 10 times 2.67 is 26.7 kilometers. So we can say Mr. Chandike passes Mrs. Snedden at after 2.67 hours and at 26.7 kilometers. Okay, now let's have a look at Albertson and Snedden. So Albertson's equation is 5t plus 12, and that equals to 2.5t plus 20. And rearranging this, we're going to get 5t minus 2.5t equals 20 minus 12, and we have 2.5t equals 8, t equals 8 divided by 2.5, and we get 3.2 hours. Now, we can't use Chandikay's equation here because those are the two equations that we're not actually using Chandikay's equations here. So I'm going to say let's use Albertson's equation. So we're going to get 5 times 3.2 plus 12, which gives us 28 kilometers. So what we can say is for Albertson and Snedden, Albertson passes Snedden at 3.2 hours and after 28 kilometers. Okay, so this is the simultaneous equation part of the linear algebra, folks. All right, so let's go to the last question. So in this one, we are saying that just the starting point of the teachers so that they finish the race at the same time. I guess because I haven't actually said whose time I want you guys to finish with, like, I mean, let's face it, we could actually say, okay, adjust the distance so that like everyone finishes at Chandikay's time, or we can say adjust the distance so everyone finishes at Albertson's time. What I'm going to do is I'm going to keep Chandikay as the standard one. So we want everyone to finish the race because Chandikay, because what did he take? He took 4.2 hours to complete 42 Ks. So we're going to keep that as the standard number, and we're going to make Miss Albertson and Miss Snedden also finish the race. So they're going to complete 42 kilometers after 4.2 hours. All right, so we got to adjust Albertson and we got to adjust Mrs. Snedden. Now, Albertson's original equation was this. All right, she was still running at 5t, but she had a 12k head start. Now, we don't want her to do 12k head start because she's not going to take 4.2 hours. She's going to take a bit longer. So what we are going to do is we're going to change this, and we're going to call this 5t plus c. But what we do know is we want her to take 4.2 hours to complete 42 kilometers. Now remember, 4.2 hours is t, 42 is distance. So we can replace this in the equation. So we're going to get 42 equals 5 times 4.2 plus c. And when we do that, we're going to get 42 equals 21 plus c. And when we rearrange it, we get c is equal to 21, which means Mrs. Albertson needs a 21 kilometer head start to complete to finish the race at 4.2 hours and 42 kilometers. So let's have a look at Mrs. Snedden's. Mrs. Snedden's original equation was 2.5t plus 20. All right, and if we were to do this, we got 2.5t plus c, because we're trying to figure out what her new starting point should be. And again, we want her to finish at 4.2 hours and 42 Ks, 4.2 being t, 42 being the distance. So we got 42 equals 2.5 times 4.2 plus the new starting point. So 2.5 times 4.2, we've got 10.5 plus c, which means c should equal 31.5 kilometers. Sorry, let me just do that one more step. So you got 42 take away 10.5, 31.5 equals c, which means you can say Snedden needs a 31.5 kilometer head start. Cool, and that's basically it, guys, for this big question here. The reason I kind of did it into 6 parts is I guess in the first 2 parts, the first 2 bullet points you can get achieved. The second two bullet points you can get merit, and the last two bullet points is kind of looking at the excellence territory. Okay, that's basically it for this practice session, folks. Thank you for watching, and if you have any questions, pop it in the comments below or just send an email and we'll try and get back to you. Okay, thanks again for watching.